Hi, and welcome to the second particle animation tutorial. So this is what we're going to be creating in this tutorial. So basically we take the built-in rubber toy, and then we'll use a sphere to chop out sections of the so progressively chop out areas on the rubber toy, and then we're going to use that newly created inside edge to emit particles from, and then we're going to do some cool stuff with swirls and particle scale, and also a ramp to drive the color. So let's start. Just move that over there. And let's start with this one. So save your HIP file to start with, as always. Save as. I'm going to save it to my desktop and just call it particle dissolve. Have I got another one already? Okay, I'm going to call it particle dissolve 3 because I've got a whole bunch of files there already. I'm going to call it Vid1 as well on the end. Okay, so we've saved that. As we do most often to start with, we'll make a geometry node. Name it dissolving object, or dissolving obj. Dissolving obj. Yep. So dive inside the geo node and add a rubber toy model. So yep. And as well as that, let's add a sphere in as well. Okay, so make sure the sphere is a polygon. As we're going to be using the sphere to cut away at the rubber toy with a Boolean SOP, we need it to be polygons. So set the sphere to a frequency of 5 for now. To keep things somewhat responsive. We'll keep things sort of low res as we're working, and then we can go back later and put things, turn values up to add more detail. So we're going to animate the sphere to cover the toy in an animated way. So add a transform after the sphere. Let's activate that, and we'll template the rubber toy. So I'm going to animate the transition and scale to cover the toy over about 200-ish frames. So this is one of the rare instances that it might be quicker to do things directly in a viewport with a manipulator handle gizmo thingy, which is this here. So let's, I'll just animate that from here. So translate position and scale. So I'm going to start with it up here and have it scaled down to about that size. Start it kind of in the front, then over 200 frames. Let's animate the scale. Actually, we'll do the position first. We'll place it sort of in the middle. Set keyframes, and then we'll animate the scale up so that it encompasses the whole thing. We've still got a little bit of the feet sticking out here, so let's go maybe 1.3, maybe 1.4, just to make sure we've covered everything. Okay, let's have a look. So it's doing that. It's kind of cool. Okay, you can fine-tune this as well if you want it to sort of wipe on the nose and then move to the head and maybe hold there for a little bit and then, you know, move down over the body, but I'm just going to leave it like that. That's not too bad. So let's have a look at the frequency of the sphere. We could probably animate that as well over the time from 5 at the start to frame 200. Let's animate that to maybe 30, so that we've got a nice amount of resolution. Yep. Okay, next let's add a Boolean. So a Boolean can be used to use cut mesh from other mesh or create intersections, all sorts of cool stuff. So put the toy in the left and the ball in the right. Change the boolean to be subtract, because basically we want to chop the ball out from the rubber toy. Okay, so I think that's all we need to do in that at the moment. Let's just turn all that off and we'll see what that's doing. Okay, so the boolean is happening and it's chopping away at the rubber toy. It's doing some nice cool things there. And then it goes to the body, the tail, and then ends at the ends of the feet, which is great. So, within the boolean, we wanted to generate some groups, because what we want to be able to do is access this inside edge here, and also these outside. Sorry, not inside edge. It's more like the polygon primitives that are created here, and also we want to be able to separate these polygon primitives out here as well. So turn on the second and third groups. So we want to do A outside B, which is this, and then B inside A, which is this area in here with the these new faces. Okay, so if we go up, let's see how it goes with. We'll deselect that. So if we go up to object level, maybe the booleans. Oh yeah, the boolean is active. To make that boolean happen a little earlier, I might move the sphere a little bit closer to the nose on the first position there, so that it starts moving. Yeah, maybe even closer. Yeah. Okay, that should do. So there's a couple of things going on with the polygon primitives that have been created by the ball. I think, let's have a look. So I think the normals are facing the wrong way because the ball was actually facing out. So I think the normals on this edge here are facing the wrong way, and they're probably the color of the ball. So I want to flip the normals back outwards on the test, on the result of the boolean. So if I add a normal and then check to see what that's doing, it seems to have fixed that, but as I mentioned, that the color of this is actually driven by the ball or the sphere. So we could add a color node in here and color the ball first to make it a nice sort of bluey color, maybe a little bit bluer than that, just so that it's similar to the thing. Or we could actually take that color and make sure that the color is being assigned to points. Actually, we might need to, actually I'll leave it at points at the moment, and I'll show you why we're going to change it to vertices. If I color that, it'll color the whole thing. But what we actually want to do is assign it just to this group in here. So when we made these groups out here, we can utilize these to do stuff in here. So I'm going to, I think it is B inside A that I'm looking for, because it's this. Yeah, there we go. So we're only applying it to the points. But at the moment, because we're applying it to points, it looks like it's bleeding out of here a little bit, but I think we might be able to fix that with vertices. Yeah, there we go. So each point has multiple vertices, or can have multiple vertices. So the vertices belong to these polygons in here, and the points can actually be shared across here. So if we assign it to points, it could be coloring this side and that side at the same time, whereas vertices can belong to just these polygons in here, or these polygon primitives in here, and not the ones out here. So we're assigning to vertex with that. So that sort of shows that you can use groups to color vertices and not have the color bleed over the edge. So the surface being created by the boolean, this perfect sphere edge here, surface, it's a bit smooth. So let's break that up by adding some noise to the surface. So add a mountain sop to the sphere after the transform. So I'll do that and do a mountain. And you can see what it's actually doing there. It's roughing up the sphere. So I've actually had some issues when using mountain or noised up spheres to use booleans, because I think sometimes the when the sphere is a bit smaller and the yep, there we go, that's exactly what I was looking for. So the height of the mountain is actually causing this to kind of collapse on itself, see here, and it's having some issues trying to do the boolean. So what I might do is animate the height of the noise or the mountain from 0 up to maybe 1 here, maybe around frame 35. It's just to basically take the problem of intersecting meshes and stop it from intersecting on itself and thus causing problems trying to solve a boolean with a solid. Because we're the boolean here, we're actually saying we're working with solid shapes, and if the sphere is turning itself inside out and intersecting with itself, the boolean's having some issues trying to figure out what's inside and what's outside. So I added the mountain SOP after the transform because of this. Now I've got a file here that I created earlier. I've got a sphere and I've split that out twice. I've got a mountain SOP that's exactly the same on the both. That's actually referenced from that, so that means that all these values here are actually driven by these values here. You can do that by right clicking on a SOP, go to actions and create reference copy, and that basically means that anything that you change on this will get changed on this. It just hooks up all of these by default, which is really cool. The transform is also instanced across as well, so they're both doing the same movement, but the only difference is that this one here moves this one up. So you can see that there's a noise applied or a mountain applied to the geometry, and then it's transforming. But what happens if I take this mountain here from the one that's on the bottom and then put it after the transform? You can see that the sphere is actually moving through a sort of the noise field, which is in sort of world space now. So that's a really good sort of thing to think about, like the order of things getting added in, especially after or before a transform can modify or change the way that it acts in quite a dramatic way. And I really like this effect, so that's why I decided to put that mountain after the transform. If I just highlight this, and we'll see as it's moving through, you can see it's sort of moving through a noise field, which is kind of cool. You could add offset as well to you know, make it look like the motion is moving up. You can animate that offset. I'm just going to leave it simple for the moment. So other than the height animated up from 0 to start with, and then up to a value of 1 at around frame 35, most of the, I think all the default values are actually fine for what we're going to do here. So we have to double check now that the let's have a look and see what's going on. Double check that the whole toy disappears now that the mountain's on, because the mountain might make it so the sphere doesn't fully cover the toy. And we're getting to the end. And yep, everything's disappeared. That's great. That's exactly what we want. So what we've got is the toy. We're getting booleaned by a sphere, and then we're colouring the recreated edges with the groups that were created in the boolean. What I might do now is, because we've got that working and it's kind of how we want it, see how it's kind of slow to work with? I'm going to cache this. I'm going to do a file cache on this, because we're not going to change anything on this for the moment. So if we cache it out when we're working with our particles, the boolean stuff doesn't have to get calculated on every frame. So we can do a file cache. I'm going to take the hip name out of the geometry file. Now, as we know, we saved the hip file, and it's going to reference everything from that position. It's going to create a folder called geo, and then the OS, $OS, is basically the name of the operator. So I'm going to call this toy ball toy boolean. So that's going to basically put that into there. So we know that inside there, inside that folder that it's going to create, it will make a sequence of files called toy boolean with the frame number and then the file extension on the end. So what I might do is I'll hit record on this, save to disk, and because that's caching out, I will stop the video now and then come back and continue once the cache is finished.